In this lesson, we explore why Sheerpower is uniquely suited for vibe programming, the workflow where you describe intent in English and let an AI generate the code. Sheerpower's design eliminates many of the syntax pitfalls common in AI-generated output, making it an ideal language for rapid prototyping and production systems. What is vibe programming? Vibe programming means you describe intent in English, and then AI writes the code for you. Your role as the developer is to validate and iterate, to run the program, check the results, and refine the intent. In this workflow, syntax errors slow the loop. Every small mistake breaks momentum and forces unnecessary repair cycles. This is where Sheerpower reduces those errors. By keeping the language small, consistent, and readable, Sheerpower makes AI-generated code easier to verify, faster to fix, and quicker to move from idea to working program. In this section, what you will learn is why Sheerpower minimizes AI errors, and how natural language prompts map cleanly to code. You'll see how views and clusters power fast data tasks, letting programs stay efficient without extra tuning. We'll also cover why Sheerpower eliminates common bug classes, removing entire categories of errors that often appear in AI-generated code. And finally, you'll learn how vibe prototypes become production-grade, so the code you generate doesn't stop at experimentation, but is ready for real-world use. This focuses on low cognitive load. The problem is that AI-generated code breaks on syntax, braces, and boilerplate, slowing down iteration. The solution is that Sheerpower keeps syntax small and consistent, reducing the surface area where mistakes occur. The efficiency comes from fewer repair loops, which leads directly to faster vibe cycles. The takeaway is that smaller languages produce more correct first-pass AI output, making vibe programming smoother and more reliable. Here we see why small syntax helps AI. With no manual memory management, and no pointers, no GC tuning, the language removes entire categories of complexity that often confuse AI-generated code. Sheerpower focuses on core types, string, real, and Boolean, keeping the type system simple and predictable. Visual suffixes, $signs for strings and question marks for booleans, clarify intent directly in the code. Finally, consistent patterns across features mean that once an AI learns one construct, it can reliably generate others. The result is fewer syntax errors, clearer intent, and faster iteration. This section shows how intent-focused syntax matches natural language prompts. You start with a prompt, and it maps directly to English like Sheerpower. For example, a prompt that says load, filter, sort, print formatted translates cleanly into code with the same structure and intent. The result is readable operations with minimal ceremony, where the code closely reflects what you asked for and is easy for both the AI and the developer to understand. This example shows natural language to code in action. You start with a simple intent, load CSV, then filter, sort, and print the results. In Sheerpower, this becomes a cluster input that reads the data once, followed by clear steps to include, sort, and then for each row, produce output. The structure of the code mirrors the structure of the request, making it easy to verify correctness and iterate quickly. This part shows how views and clusters make data work fast by default. The problem is that AI often generates slow parsing loops, especially when it relies on manual indexing and repeated string copying. The solution is to use view plus cluster patterns, which require no indexing logic at all. The result is efficiency through zero-copy parsing and fewer allocations. The takeaway is fast data code with minimal prompting, where performance comes naturally without extra effort from the AI or the developer. This example shows log parsing with views. Using a piece's view per row, each line is accessed directly without creating new strings, resulting in no substring copies. The program then counts errors as it processes each row, and it knows when to exit when empty, stopping cleanly at the end of the data. This approach keeps log parsing fast, efficient, and easy to reason about. In this approach, this explains declarative queries without SQL strings. Instead of writing SQL, you use a clear sequence: extract table, then include, sort, and for each row, process the results. There are no SQL strings, which means no injections and fewer syntax or escaping mistakes. The result is readable data operations, where the structure of the code clearly expresses the intent of the query and is easy for both the AI and the developer to review. This part demonstrates how built-in safety and precision eliminate entire bug classes. With real equal to exact decimals, financial and business calculations behave predictably and correctly. Sheerpower provides safe conversions, which helps prevent subtle type errors. There are no floating point penny bugs, because decimal math is exact by design. In addition, there are no resource leaks, and strings are handled safely, removing entire categories of failures that commonly appear in AI-generated code. The result is more reliable programs with fewer surprises. This shows how Sheerpower moves from prototype to production. You get fast execution, so programs perform well even as they grow. There is a built-in spins web server, so applications can expose endpoints without extra frameworks. And with direct CSV/JSON workflows, data can move in and out of programs cleanly and efficiently. This explains why Sheerpower is ideal for vibe programming. Versus Python and JavaScript, there are fewer edge cases for AI to get wrong. Versus C++ and Rust, there are fewer low-level traps, such as pointer and lifetime issues. And versus many other languages, Sheerpower is faster, cleaner, and safer for AI, making vibe programming feel natural, predictable, and frictionless. To summarize the key takeaways. Small syntax leads to fewer AI errors, because there is less surface area to get wrong. An English-like structure leads to better prompt mapping, so intent translates cleanly into code. Views and clusters lead to effortless high performance, without manual tuning. Declarative queries lead to fewer mistakes, by removing fragile query strings. Exact math leads to safe business logic, especially for financial applications. And faster vibe loops lead to faster delivery, turning ideas into working software more quickly.